Section 7-5 from webwork. Okay, there are 15 problems in this section. Let's go over those one by one. Problem 1. Evaluate the integral 1 is sin x plus 1 secant x over tan x dx. Okay, so let's go over this. Sin x plus secant x over tan x, integral of this expression. Well, this is a trigonometric one, so let's try simplifying first. Sin x plus secant x. Secant x is 1 over cosine. Tan is sine over cosine. Common denominator upstairs is cosine. So sin x cosine plus 1 over cosine, sine over cosine. So both the denominators cancel. You are left with this. Now you see, there are two terms in the numerator. So why not divide? So sin x cancels, you are left with cosine x plus 1 over sine is cosecant x. Fortunately, integral of cosine is straightforward. Sine, integral of cosecant is straightforward. These come from our formulae. Natural log absolute value cosecant x minus cotan x plus constant of integration. So let's try. Sine of x plus natural log absolute value cosecant x minus cotan x absolute value plus constant of integration. Good. Next problem. Integral of negative 2 over square root x plus 1 plus square root x dx. Whenever you have a radical expression of this kind with a separation, you see, it helps to rationalize the denominator. So because this is a sum of two radical expressions, multiply numerator and denominator by the difference of those two, you see. So numerator is negative 2 square root x plus 1 minus square root x. Denominator is difference of squares. That's a plus and that's a minus. So the first term squared minus second term squared. So numerator continues as it is. Denominator is x plus 1 minus x. Well, that's simplified to 1. So all you have is negative 2 square root x plus 1 minus square root x dx. Now this is straightforward because this is just power. X plus 1 power half. X power half. You can simply take the integration. X plus 1 power 3 halves over 3 halves. So over 3 halves gives me a 3 here and 2 above. With the 2 became a 4 above. So that's a negative and the same story here. So let's try and substitute. Negative 4/3 parenthesis, parenthesis and a parenthesis. X plus 1 power 3 halves minus x. I think something is off here. There. Power 3 halves plus a constant of integration. Good. Next problem. Integral negative 1 to 1, negative 8 e to the arctan y over 1 plus y squared dy. So notice arctan y and 1 plus y squared are related. Well, let's see. Set u equals arctan y, then du is 1 over 1 plus y squared dy. So you see all of that is du. So you have that should be a negative 1, negative 1 to 1. When y is negative 1, u, which is tan inverse of negative 1, that's negative pi by 4. When y is 1, u, that's tan inverse of 1, is pi by 4. So this negative 1 to 1, negative 1 to 1 becomes negative pi by 4 to pi by 4, negative 8 e to the u du. Well, integral of e to the u is e to the u with limits. So negative pi by 4 to pi by 4. That's it. No constant of integration needed because this is a definite integral. So mind you, I have a small typo here. It should be -1 to 1. -1 to 1. So let's write down the solution. -8 e to the pi over 4 minus e to the negative pi over 4. Good. Next problem. Integral 8 sine cosine of cosine x dx. So that tells me that cosine x should be u. Okay. So that cosine x is u. So du would be negative sine x dx. So that's a negative. So sine x dx is with the negative is du, and u itself, that's the inner cosine. So cosine of u du. So integral of cosine is simply sine. Don't forget there's a negative. And plus constant of integration. Replace the u by cosine x as that was your substitution. So -8 sine of cosine of x plus constant of integration. Integral 9 sine to the power 3x cosine to the power 5x dx. Well, this is a nice problem. I can take u equals cosine x. Then du will be negative sine x dx. So of the 3 powers of sine, I will take away one aside. Okay? There should be a negative somewhere, right? So there should be a negative somewhere. All right? So du, correct. There you go. There's the negative. Now what do I do with sine squared? 1 minus cosine squared. So all of this is 1 minus u squared. That's u to the power 5. Sine x dx is du with a negative. Okay. So 9 is the constant that came with my question. So it continues. Now this is simply polynomial, you see. I can multiply, distribute u to the 5 minus u to the 7 du minus 9 here. Now when I take integral, this is u to the power 6 over 6. This is u to the power 8 over 8 minus 9. Now we are done, except you need to resubstitute u equals cosine. Okay, so -9 cosine to the power 6 x over 6 minus cosine to the power 8 of x over 8 plus constant of integration. Check. It works. Okay. So next problem I'll continue in our next video.